Hi Pavan, hello, okay. Okay, good to see you guys. How are you guys doing? All right. Okay, so first of all, let me welcome you guys to the Unacademy JEE English. This is a brand new channel by Unacademy, and here everything is taught to you completely in English. All right, so this is a series that I host for class 11 students. All right, and we have been taking up class 11 topics and going through the very basics of all of them. So this is lecture 8 of Newton's laws, and today we'll be starting discussion about the laws of the friction force. So we had earlier talked about all the other forces. We talked about Newton's laws. We talked about application of Newton's laws. So okay, why is the stream not starting? That is weird. All right. So I have started the stream, but I don't know what is happening. Uh, Let me see. Let me see. Okay, that is so weird. Yes, yes, yes. I know, I know. Let me restart my stream. I don't know. There is something wrong. Yes, yes, I know, guys. So let me restart my stream. Let's see what the problem is. I'm good, Chinmay. Thank you for asking. Yeah, but I don't know what is wrong with this. The stream is not running smooth. Okay, that is weird. All right, all right. So let me know if you guys can see me, hear me. All right, can you guys see and hear me? All right. Just let me know quickly because I don't know. From my end, also the stream is hanging a bit. I don't know why it is freezing. All right, how about now? How about now? Is it fine now? Is it any better now? Okay. Yeah, there is some weird delay. I don't understand why. Yes, I know. So let's give it some time. Maybe it'll become smooth. Maybe it'll become steady. All right. Hmm. Okay, guys. So I don't know. I just restarted my software, but I don't know what is happening. All right. Let me check my net speed. What seems to be the problem? Okay. Yes. 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 It is giving me a lot of trouble. I don't know why. I know. I understand what you're saying. So let me see. I'm just checking up my speed, net speed. I don't know why this is happening like this. Okay. Okay, so the net speed seems absolutely fine. So the problem is not with the net, it is with the software, I guess, which is strange. Okay. So yeah, I know. This is very weird. This all right. So I have finally restarted my computer, and I think and I hope that things will be better now. All right. Yeah. They definitely seem better now. All right. Never mind. So, all right, as I was saying, guys, first of all, welcome to Unacademy JEE English. All right, so this is a brand new channel by Unacademy, and on this channel, everything is being taught to you completely in English. And this is lecture number 8 of Newton's laws, and today we'll be talking about friction. All right. So, before we get started, let me introduce myself for those of you who don't know me. So, my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and I've been teaching physics for almost 8 years now for IIT JEE. I myself was JEE rank, All India rank 447 and All India rank 192 in the two stages of the JEE exam that I took. Now, I also qualified the NTSC stage 2 and I was in the top 1% in the national standard examination for physics. And I've already coached many students to top ranks in the JEE exam. All right, so yeah, a lot of you, they left the stream and you have hit the dislike button also. Okay. Okay. So not really my fault, guys. So sorry. I don't know what was wrong. When I restarted my computer, everything became just fine. All right. So anyhow. So let me also tell you about. Yes. I know. I can see that myself. I am watching. I opened a YouTube window myself to watch how it is going. So as I was saying that the Unacademy subscription brings you benefits like live classes, you get to interact with your educators, so you get the feel of your offline classes from the comfort and safety of your home. Then of course these classes have live polls and leaderboards, so they are highly interactive. They keep you involved, and so that the learning is not only continuous without any break, but it is also fun. Now you also have test series and analysis which help you a lot because this is such a highly competitive exam that you need regular assessment. And of course, the best feature is the live doubt clearing sessions. So with the Unacademy sessions, as a matter of compulsion, every fourth session in any Unacademy course has to be a live doubt clearing session. So with Unacademy courses, your doubts are always taken care of. Now, on top of all these benefits, you are getting access to India's best educators with this subscription. So, how do you get the subscription? Very easy. So, first you need to go and install this app. Once you have done that, you go to the plus section in your app, you select your goal as IITJ and you click on this get subscription button. All right. And once you are on the payment page, you can use this code. This is my code. If you use this, you will get 10% off on the subscription fees. All right. So you will get 10% of any of the plans that you select here. So every price will get reduced by 10% for you. All right. So next, if you're following us on the JEE English channel, then you can connect with us on the Telegram app using the link shown above. All right. And so finally, let's get started with today's lecture because there has already been so much delay. All right. So today we'll be talking about friction. So in earlier lectures, we talked about Newton's laws. We talked about different forces like normal reaction, tension, spring forces, and we left this force out. Why? Because it is one of the most complex forces, and this needs to be studied separately. So today we'll be talking about friction, and I hope everyone has watched all the other lectures and are familiar with what exactly Newton's laws are and how we apply them in questions. So that knowledge, trust me, is needed before you start understanding things about friction. All right. So let's get started. So what is exactly friction? So friction is a force that opposes the relative lateral motion or tendency of relative motion between the two solid surfaces in contact. So what do I mean when I say relative lateral motion or tendency of relative motion? So suppose a solid and a solid, these are in contact. So they can have relative motion either perpendicular to the contact or along the contact. So this is called the lateral relative motion. Alright, when two solids or two surfaces in contact are moving along with respect to each other along the surface of contact, that is called lateral relative motion. So friction is the force that opposes this motion. Alright, now in your daily experience, you know that if I set something in motion, it will come to stop. While Newton's first law says that this should never come to stop once set into motion unless there is a force. So obviously there is a force which is opposing this motion. That is what we call friction. Alright, it was because of friction that till a long time people believed that the natural tendency of any object is to eventually come to rest. Alright, so this was a theory that was given by Aristotle. And this, until the time of Newton, everybody believed this, that naturally everything wants to eventually come to rest. It was Newton who pointed out for the first time that no, that is not correct. Naturally, everybody wants to continue in its state of motion or rest. It is an external force of friction that is causing, not that is causing to stop the bodies. All right. So that is where this thing comes into play. Obviously, people realize about this very late. Now, how does this come into play? So, this force arises from a combination of factors. Okay, so there is inter-surface adhesion. So, what is adhesion? Adhesion is attraction between two different kinds of molecules. All right. Then there is surface roughness, surface deformations, and surface contamination. So, a lot of factors go into the causing of this force. So, the old theory, initially, when people realized about friction, what explanation they gave was that it is called due to interlocking of irregularities. So obviously, they thought that if I look at any surface under a microscope, then all surfaces have these kind of troughs and crests. All right, so they have valleys. All surfaces have valleys. So they thought when two objects are being kept in contact, so this is what is happening. Their rough surfaces or uneven surfaces are getting interlocked, and they thought it is this interlocking that is causing the force of friction. So this theory was accepted for a long time and explained how friction acts very successfully until there was a problem. All right, so because of this theory, if you say that when I keep two things in contact, their surfaces get interlocked like this, and that is what is causing hindrance in this motion. Now, obviously, somebody thought that what happens if I start smoothing the surfaces? If I start smoothing the surfaces, then obviously this force should reduce. And that is what they did. They smoothened the surface and they tried to see what are the effects of that on friction. So obviously, initially, the friction force reduces. That is in accordance with my theory. My theory says that it is happening due to interlocking, and if interlocking is reducing, then the friction is going down. Fine. But there was something weird that happens when you keep on smoothing the surface beyond a point. All right. So beyond a point, when you keep smoothing surfaces, the friction was observed to go up significantly. All right. So after some time, after a limit of smoothing, you realize when you smoothen the surfaces more beyond a point, then the friction instead of going down increases. Now that was a weird result. That was a very weird result. That did not make sense. All right. So people thought, how is that happening? If it is just the interlockings that are responsible for the force of friction, then if I keep on making the surfaces more and more smooth, the friction should have just kept on reducing, and it is going up. So to explain that, people came up with a new theory, and now we think that friction is caused by formation of cold welds at contact points under high pressure. So what exactly is that? What exactly is a cold weld? So people realize that if you actually talk about the contact, so you see here, if two surfaces are in contact with each other, the actual contact points are turns out is very less. All right. Hi Priyanshu, how are you? The actual contact surface is very less. The area is very less. So if let's say these surfaces have an area A touching each other, then the area of these points, let's call them A dash. So it turns out A dash is roughly 1 by 10,000 times A. Alright. So imagine the actual area of contact is roughly 1 by 10,000 times the apparent area of contact. Okay. No, I don't have birds in my house. I have birds outside my house. Outside my bedroom, I guess. Alright. So I guess, yes, you can hear some birds. So, yeah, that those are not in my house. They're outside my house. Okay. Yes, I can hear them too. All right. So what happens? What happens is that because the area of contact is so less, all the normal reaction we talked about this, that whenever two solids are in contact, they apply a normal reaction force on each other. So all that normal reaction turns out is coming from this very small area that is in contact. All right. So that is what is happening. First thing you need to understand: all the n is getting exchanged from these points. Now, because of that, what happens is suppose the normal reaction between a few points is let's say 100 Newton. All right, if it's a 10 kg block. Now, all the 100 Newton force is divided into these small points. It is acting along these small points. All right. So what happens is that due to that, on these regions, a very high pressure area gets developed, and this high pressure makes these two molecules of two different surfaces come very close. And when they come very close, so what happens is that they start forming some sort of bond between them, which is called adhesive bond. By the way, adhesive is attraction force between unlike molecules. All right, so because they are so close, so they have some inter molecular forces acting between them, which are the adhesive forces. Now they result in formation of something which we call cold welds. So what are cold welds? Just like hot weld, you must have seen if you wanted to stick two plates. Let's say if you wanted to stick two plates of metals together, what do? So let's assume one plate is iron and one plate is, let's say, aluminum. If you wanted to join them, what would you do? You would just heat both of them up. So here you would heat them up. If you heated them up, what will happen is that the molecules from, let's say, aluminum would start fusing into molecules of if of iron. See, in the solid state, these molecules couldn't have come very up close. Why? Because all the iron molecules are very close. All the iron atoms are very close. All the aluminum atoms are very close. But the moment I provide them heat, the moment they start melting, so these are getting apart. These are getting apart. Now they can find themselves in spaces between different molecules. So that is what is happening due to heat. Okay, due to heat, you will have some iron molecules which got separated, and in the middle, maybe aluminum molecules will come in the middle. And these, because they have come so close, different molecules have come so close, they will start attracting each other. They will form bonds between them, and when you let it cool down in solid state, you will realize that these molecules would be very close to each other. And when they are this close to each other, they start forming something which we call hot welds. All right, so cold weld is something like this only. In hot welding, what you're doing is you are heating materials, heating them and trying to put them together. So because of heat, because of their thermal agitation, see, the molecules are constantly moving here and there. So they end up coming close to each other and they end up interlocking atom to atom. All right, all their atoms are coming very close. And once they come that close, they start attracting each other. So once you let this cool off also, you will see that the two plates would have joined. All right, and it would be very difficult to separate them. Now, on the other hand, in cold weld, the atoms are brought so close to each other via high pressure. So by applying very high pressure, you're just pushing them together. You're just pushing them together. If you push them together hard enough, they will start forming, they will come so close to each other that they will start forming some adhesive bonds between them. All right, and that is what you call cold welds. All right, so that is how we explain that this force is acting. All right. So what was happening? What was happening was that we realized that the strength of these bonds, by the way, strength of cold welds is directly proportional to pressure of cold welds is directly proportional to the pressure. So higher the pressure between two molecules, the stronger would be the cold weld. All right. So initially, what is happening is that when you're smoothening it, suppose when you're smoothening this surface. So why was the friction going down? See, the friction was going down because initially, let's say when you smoothen this slightly, so this surface became wider. This surface became wider too. All right. So this is what is happening. Initially, the surfaces are becoming wider because of this pressure on these points is getting reduced. But when you completely remove this, then what happens? Then what happens is that instead of 3 points of contact, maybe after some time of smoothing, you are left with only 1 point of contact. All right. And the contact at the other 2 points has completely disappeared. Now, though you could have thought that the force would remain the same, but turns out the pressure here becomes so high that the new welds that are forming are way stronger than the old weld. Hi Ram Reddy, how are you? So that is why the friction tends to go up beyond a level of smoothing. Okay. So let's talk about some more properties of friction. Again, the cause of friction is not really discussed much because we ourselves don't really know much about it. We just have some theories. All right, that is why you don't need to bother about what exactly is causing friction because IIT would never ask you questions on that because that is an area where we are still developing theories. All right. So what needs to be focused more upon is what we know for sure. So this is the properties of friction force, which we know for sure, all right, which we have observed from experiments. So first, obviously, friction is a contact force, and it is electromagnetic in nature. As I said, the cold welds are formed due to, attraction between molecules of two different kinds. So obviously, that those attractions are electromagnetic in nature. All right, so that is what you need to remember. This is important. So it is a contact force and it is electromagnetic in nature. Next, you will see that it always acts tangential to the common surface. All right. So why is that? It always acts tangential to the common surface. Why would it only act tangential? See, if two surfaces are in contact, their bonds have been formed. What happens if I try to lift them? The moment I'm trying to lift this, I'm decreasing the pressure at the surface points. When I decrease the pressure at surface points here, the cold welds automatically weaken up. They start weakening up. All right. So when I get this, move it like this. So all that will happen is that the bonds will just start weakening up among themselves. They do not sustain themselves unless the molecules are forced together. So the moment you reduce your N, they just start weakening their bonds and they just separate like this. So this kind of motion is not opposed by friction. All right. However, if you have kept them under high pressure and now if you try to slide them, then the bonds oppose this. All right. So that is why this force is always tangential to the contact surface. Next, if there is no slipping, so there can be two conditions. There can be two conditions. Either there is slipping or there is no slipping between two surfaces. So if there is slipping, then friction acts in the direction opposite to that of relative motion. This is very important. So you just need to remember one thing that is that friction always opposes relative motion. It does not oppose motion, it will only oppose relative motion between two surfaces. All right. So if there is slipping, so suppose if this is kept here and if I push this, so the relative motion's direction is, so the phone with respect to my hand is going forward. So on this, the friction will act in the backward direction. Similarly, if I kept my phone stationary and I move my hand like this, then what is happening is my hand is going forward. So with respect to the phone, hand is moving forward. So on hand, the friction will be backward. And when I look from my hand, what does that see phone to be doing? It sees that the phone is going backward. So it applies friction on the phone in the forward direction. So please remember that. If there is slipping, the moment you see slipping or a relative motion between two surfaces, then you immediately find the direction of relative motion and the force of friction would be opposite to this direction. All right. If there is no slipping, then friction will come into play only if there is a tendency of slipping. Please remember, just like normal reaction, we discussed this in normal reaction also. Alright, what did we discuss? That if suppose this block and this block are kept in contact, if two blocks are kept in contact and just left there will be no normal reaction coming into play till the time they have a tendency of relative motion along this surface. Alright. So if this guy doesn't want to move here and this guy doesn't want to move here, then there is no need for normal reaction to arise. It will arise only if there is a tendency of motion along perpendicular to the surface with respect to each other. Similarly, the friction will come into play only if there is a tendency of relative motion along the contact surface. So if this guy wants to move like this, or if this guy wants to move like this, then only the friction will come into play. So suppose you have ground, and on this ground you had a block kept. Alright, if the block is just kept there, then there will be no friction between the block and the ground. Remember this. The friction will only come into play if the block tries to move with respect to the ground. Okay. So even if I'm holding these two and I'm pulling both of them together, if I am pulling both of them together, then there will be no friction acting between them. If I have kept this and I'm pulling only the thing below, now the friction comes into play. Alright, so remember this. Alright, let's talk about the next point. The next point says that this is a non-conservative force and causes dissipation of energy. So what is non-conservative force? We will talk about that in the next chapter, which is work, power, and energy. Alright, for now what you need to do is friction causes dissipation of energy. Alright, friction, again, we will talk about the details of this in the next chapter. So remember, from this point, from this sheet, just remember these things. One, it is a contact force. Second, it is electromagnetic in nature. Third, if there is slipping, then the direction of friction is always opposite to the direction of relative motion between the two surfaces along the common tangent. Okay. Next, if there is no slipping, then friction acts in the direction needed to prevent relative slipping. Alright, so remember this. Next, so to understand friction, people did some experiments. Alright, so here is such an experiment, and let's see what we observe from this experiment and what we learned. So what they did was they kept a block. Let's say you kept a block and you are trying to observe this. So if this block is stationary, so what conclusion do I have from my first law of Newton? The net force on this has to be zero. So if I look at all the forces from my knowledge so far, if I look at all the forces acting on this, from my knowledge so far, I know that it has a force mg and it has a force of n. Alright. So these are the two forces that are acting. Now in the horizontal direction, there is no external force, which means there cannot be a friction, right? Why? Because the net force in x direction should also be zero if this is stationary. If the net force in x direction is zero, that just means that can there be any friction? No. If there was a friction, then it would have moved. So if there was a friction, it would have moved. I'm just assuming a direction to friction. So my conclusion when I look at this is that F has to be zero. So here my conclusion is, if this force, external force, if there is an external force and that is zero, then F has to be zero. So alright, that is the first thing that I can conclude by looking at it. That if F equals 0, I realize F is also equal to 0. Alright, so I plotted this. This is a plot that I am making between the force of friction and the external force F that has been applied on it. Now let's increase the force capital F slightly. So when I increase the capital F force slightly, let's say I apply a 1 Newton force and I still don't see this phone moving anywhere. So what is my conclusion? My conclusion is, again, if this is not moving, then force of friction must be equal to F. There has to be some force which must be balancing this, right? And who can that force be? Where can that force come from? The only place that force could have come from was this friction. Alright, so I know even if I applied some force and this object did not move, some force must have come into play which opposed or balanced this force. Alright. So that force can only be friction. And how much friction, in fact? See, still my acceleration is zero. If still my acceleration is zero, so if I apply a non-zero small f and I still see no motion and see no motion. So what do I conclude? If I see no motion, the net force has to be zero, which means F minus F should be zero, which would give me F equals F. Alright, so suppose I had applied a force of 1 Newton, then now a friction of 1 Newton must be acting, which must be balancing this force. So I can plot another point of 1, 1 on this graph. So I get another point. Now suppose I increase this force. If I increase this force slightly, I still don't see this moving. Alright. So I still don't see this moving, which means the friction would have increased. So I keep on plotting this. I keep on increasing my capital F. If I keep on increasing my capital F, try to find the value of small f from F equals ma equations. So I'm seeing what I will observe at what I see, and okay, some force, no movement, so friction must be equal to, let's say, if this force is 1 Newton, friction must be 1 Newton. If I increase this by 2, still no motion, now friction must be 2 Newton. If I increase it further, 3 Newtons, still no motion, friction must be 3 Newtons. Now I will see if it suddenly moves at a point. So let's say at some point, at some force, some value of force, this moves. Now when it is moving, can I still find the value of friction force? Of course I can. How? Let's say at some force this starts moving. Now all I need to do is calculate the acceleration. How do I calculate the acceleration? I can see the motion. I will find how it is moving with respect to time. So I will calculate the acceleration. Once I have calculated the acceleration, I will know. Alright, so let's say if F is non-zero and block starts to move, and block starts to move. Now what do I conclude? That the block has some acceleration, and I can measure that acceleration. I already know the force that I have applied. So I can say that F minus small f equals ma, where a is the acceleration that I will experimentally see. Okay. So from here I could also find the value of friction as F minus ma. So you realize under any condition I will be able to find the force of friction. Now all I need to do is I will start plotting the small f's with respect to capital F's. When I start making a graph between small f and capital F, this is what I get. This is what I get. This is the kind of graph that we see. Alright. So now let's try and look at this graph. So for some time I see that the graph is a straight line of 45 degree, and so I can realize that as I'm increasing my F, the friction force of friction is also increasing up to a maximum value. It happens. And till this, there is no slipping. This is the region where there is no slipping. I kept on increasing the force, but there was no slipping in this entire region. Now beyond this point, the moment I increase my force, external force F, I see slipping happening. And now when I calculated the friction, turns out the friction becomes smaller and becomes constant for higher forces. Alright, so pay attention to this. This is what I will observe if I do such an experiment. Alright, so people did these experiments. From these experiments, they draw a graph between force of friction and external force, and this is the kind of graph that they got. So you will realize some remarkable things. One, that friction is behaving differently when the slipping has not started, and it is behaving differently when the slipping has started. Why? See, initially the friction kept on increasing. Later it became constant. So obviously I can clearly see a contrast in the behavior of friction. Alright, now that is why we divide friction into two categories. Why? Because the behavior of friction force is different for both these motions. When the slipping is happening, then it behaves differently. When the slipping is not happening, it behaves differently. So that is why I divide friction into two categories. I call this the static friction and I call this the kinetic or dynamic friction. So static friction is the force of friction that acts between the two bodies when the relative motion between them has not started or there is no slipping between the two surfaces. Alright. And kinetic friction would be the force that starts acting between the two surfaces when there is slipping, when slipping has started. Okay, so remember this. Now, here I will notice some more things from this graph. So I will notice that the friction force will attain a maximum value, and everywhere else the friction is always lesser than this. So whatever maximum value the friction force acquires is called the limiting friction. Alright. So this is an experimental result. Please remember, this is what we are observing experimentally, and then we are addressing what we observed experimentally. So experimentally I observed that friction increases from 0 to a certain value when I keep on increasing an external force till the time slipping has started. So it takes up a maximum value, and then the moment slipping starts, it suddenly drops and its value becomes constant. Okay. Hi Raju. So the maximum value that the friction takes is called limiting friction. Alright, that's the maximum value that the friction takes. Alright. And this obviously the constant value when the slipping has started is called kinetic friction. Alright. So obviously, as I said, because the behavior of friction is different for both these conditions, I need to study them separately and understand them separately. So if you guys followed the discussion so far, if you guys followed what we are trying to do, we are trying to experimentally notice the behavior of frictional force, and we are trying to notice how the friction force acts and behaves under different circumstances. All right. Next, let's talk about the key observations and conclusions. So let's just write them down. So the first key observation was friction behaves differently behaves differently when slipping has started slipping has started and differently when there is no slipping. All right, so that is the first clear thing that I'm observing. Next, what I'll observe is that so I'm dividing the friction into two categories. Based on this, I'm dividing the friction into two categories. So based on this, friction is divided into two categories. All right. And those categories are static and kinetic. So one you have static friction and another you have kinetic friction. Alright, so far this is, I am not understand. What did you not understand, Raja Dubey? Tell me. Tell me, what did you not understand? So I guess the problem is that you joined in the middle of the discussion. That is why you did not understand something. But if you can tell me what part you did not understand, I will explain it to you. Alright. Okay, no, I don't. Is there still a lag? I don't think so. The stream seems to be running fine now. There was a lag initially. If there is any lag now, I am guessing that might be because of your internet. Okay, because from my end, I am watching the stream myself, and the stream seems fine. Okay, all right. Next, obviously, we realize that. So, what about friction? Do you not understand? Tell me. What about friction? Do you not understand? I will explain it. So here I see the value of friction keeps on changing for this entire period of no slipping. When the slipping starts, then the value of friction becomes constant. So let's write those two things also down. Till there is no slipping, there is no slipping. The magnitude of the force of friction, the magnitude of the force of friction can vary. while once slipping has started, then the magnitude becomes constant. Alright. So static. Okay, so I will tell you what is happening is that to understand friction better, I performed a series of experiments. I did some experiments. So what we did was just follow this. Look at this. What we did was that I kept this, and then I started pushing this with some force. I started pushing this with some force. All right. So when I pushed this, so let's say I'm not pushing this at all. Right now, I'm not pushing this at all. So I know because the F equals ma equation tells me that the net force on this has to be zero, which means there cannot be any friction acting right now. All right. So forget about static, forget about kinetic right now. Let's just talk about friction. Can there be any friction acting? Can there be any force in the horizontal direction? In the horizontal direction, there cannot be any force. Why? Because this guy is not moving. So if there was a force, there is no other force to balance it. So that means friction is not there. Alright. Now if I apply, let's say, a force of 1 Newton, and I see that this is still not moving. So why is this not moving when I am pushing it by 1 Newton? So something must be cancelling out my force of 1 Newton. That thing must be in the opposite direction and must be exactly equal to 1 Newton. So what my conclusion would be, if my capital F is the force that I am applying. If capital F is 1 Newton in this direction, then there must be a force which must be balancing the, that is what we call in friction. So friction right now must be in this direction and it must be equal to 1 Newton. Alright. Now what happens if I increase my force? If I try to push this harder, so if I try to push this by 2 Newton, I still don't see any slipping happening. I still don't see any acceleration. For me, F equals ma equation tells me the net force is still zero, which means there is still a force which is balancing this. So now the friction would still be acting in this direction, but would have taken a value of 2 Newton. Alright. So I will keep on changing this until the time slipping has started. Till the time there is no motion. For that time, I can say that the net force has to be zero, because of which F minus F will be zero, and my force of friction must be equal to capital F. Whatever force I might be applying externally, that is always getting balanced by the force of friction. Alright. So that is the conclusion that I have before the slipping has started. Now imagine if I kept on increasing and slipping started. The moment slipping started, now I want to calculate how much is the friction acting. So what do I do after that? I know how much force I applied. Let's say I applied 15 Newton and I see it moving. If I see it moving, I can calculate its acceleration. How do I calculate its acceleration? I will take a stopwatch. I will notice the distance it is measuring, it is covering in time t, and then I will use s equals half at square to calculate the a. Once I know the acceleration of this, then I will use the equation that F minus F. There is some friction. There is some friction. Why? Otherwise, I will see acceleration equals F over m only. So assuming there is some friction, I will use this equation F minus F equals ma, and from here a I will calculate experimentally by observation. I will find my a. F I already knew. I knew both these things. I can find small f also. I can find the force of friction that is acting. So force of friction that must be acting would be capital F, which is the external force that I am applying, minus ma, where a is the acceleration that I can see. Okay. Now, if I keep on changing the values of f, so instead of 15, now let's say I apply 20 Newton, so it moves faster. Then I apply 25 Newton, it moves even faster. So I can keep applying different force of capital F, and I will keep on calculating the value of small f, and I am plotting that here. I am finally making a graph between capital F, the external force that I am applying, and every time the force of friction that I calculate, that must be acting. Alright, so if I draw a graph between the force that I am applying, capital F, and the force of friction, then this is what I see. This is the kind of graph that I see. Now, this graph I see initially as a straight line with slope 1 or 45-degree angle. At 45-degree angle, it's a straight line. And this straight line graph is seen till the time there is no slipping. So till the time there is no slipping has started, the graph between external force that I am applying, and the force of friction that I am calculating, which seems to be acting, is varying like this. Alright? It is changing like this in a straight line. Once the slipping starts, the moment slipping starts, if I calculate the force of friction now, turns out it becomes slightly smaller. Alright. Now if I increase my force F also, then also this force does not change. So this is the graph that I am getting. Alright. This is an experimental result from experiments. I am experimentally trying to find out small f due to different capital F's, and this is the graph that I got. Now what I am saying is that, okay, so this is the force of friction. The force of friction here in this region is acting completely different, and in this region it is acting completely different. In one region it is the force of friction is changing continuously. In one thing it has become constant. So because the behavior of frictional force is different when there was slipping happening between two surfaces and different when there is no slipping happening, I divided it into two categories. Alright, I hope you followed it now. And this I started calling static friction, and this I started calling kinetic friction. Okay, do you follow this? Raja Dubey. समझा अभी थोड़ा? So that is what I'm writing. These are my key observations and conclusions from the experiments. So from the experiments, I saw that friction behaves differently when slipping has started and differently when the slipping is not started. Alright. Now based on this, friction got divided into two categories. So now I'm calling friction by two names. I'm calling it by static friction if this is, I'm saying, the force of friction when the slipping between two bodies has not started. No problem. Most welcome. And then I am calling another part of friction as kinetic. This is when the slipping has started. Alright, so I gave these frictions two different names because they behave too differently, and that is why I want to study them separately and understand them separately. Okay. Now what I can also notice is that till the time there was no slipping, you see the magnitude of friction can vary. It can change. So while there was no slipping, till the time there is no slipping, the friction can have any value. It can go from 0 to a maximum value. Alright, and it could have had this value, it could have had this value. So at any different point, depending on what external force you are applying, this force can have any value between this range. It can have any value between 0 and a maximum value. On the other hand, when the slipping has started, then it doesn't matter what force I am applying, this friction always has a constant value. Alright, so that is what I am writing. So till there is no slipping, the magnitude of friction can vary. But once the slipping has started, the magnitude becomes constant. Alright. Now the maximum value of friction is called limiting friction. The maximum magnitude that friction can have is called limiting friction. Alright. So why limiting? Because that is deciding the limit on the value of friction. Alright. So from this graph I can see that friction can never be more than this. Alright. This is the maximum value of friction. Friction force can never be more than this. That is why we call this limiting friction. Okay. Now that we know friction behaves differently in two situations, so we study them differently. So why don't we start the study of kinetic friction? Okay, so before we start the study of kinetic friction, you need to first understand how the friction directions work. Alright, so here is a force. Here is a practice problem just to understand the directions of friction. So this problem says a block is resting on a rough surface with no force acting on it. So initially the condition is like this. So you have ground and then you have a block and there is no friction, no force acting on this. No external force acting on this. So you are not pulling it, you're not pushing it. This is just resting on the ground. Alright. Now you have been asked what would be the friction acting on it. So what will be the friction acting on it? Can you guys tell me? What will be the friction acting on this if this is just resting? If I'm not applying any force, then what will be the friction force acting on this? Let me know. Let me know in the chat. So let's try and get used to this friction force. Let's try and understand how it behaves in different situations. So what will be the friction acting on it? Okay. All right. See, I want you guys to answer because I want you guys to understand and think about it. Okay. So try something. Give me some answer. Don't worry about it. It's alright even if you give me a wrong answer. That's alright. You're just learning stuff now. Alright. And while learning, you should definitely try and think. Otherwise, you won't learn. If you're just listening, then trust me, you're not understanding. So to understand, you need to start thinking. And that is why I'm trying to have this discussion. Okay, so still no answer. So obviously, since there is no external force, at this time the friction force would be zero. Alright, the friction force would be zero. Okay, yes. So now if the block is pulled by a force F, what will be the direction of friction acting on the block and that acting on the ground? So let's see, now there is a force F and this started pulling. All you need to tell me is the direction of friction which would act on the block and the direction of friction which would act on the ground. So on the block, I have applied a rightward force. So this rightward force, I don't know if the slipping is happening or not, by the way. But it will not matter. Backward. Yes. Raja Dubey, you are absolutely right. So if this force is acting here, so this block is trying to move forward, the ground will not move. So with respect to the ground, it is trying to go forward. So obviously the friction on this will act backward. And if the friction on this is acting backward, how about the ground? How about the ground? What would be the direction of friction on the ground? See, if the ground is applying friction on the block will apply friction on the ground as well. There will be an action-reaction pair. Alright. So, clearly I can see that the block is being pushed by friction backward. So, as a result, the friction that this block will apply on the ground would be forward. Please remember, action-reaction pairs. So these two force of frictions would be action-reaction pairs. This is the force that the ground is applying on the block. When the ground sees the block, what does the ground see? The ground sees that this is trying to go forward. So on this, it applies friction in the backward direction. Now, when the phone sees the ground, what does the phone see? Phone sees that the ground is going backward. Alright. So if the ground is going backward, the phone will apply a force of friction on the ground in the forward direction. So please remember that. And these two are action-reaction pairs. They will always have equal magnitude and opposite directions. Alright, so please remember this. That whenever friction is acting on one body, there will be a reaction also which will be acting on another body also. Okay. Alright. So please remember this. Yes, absolutely. Absolutely. Alright. So now let's try and talk about kinetic friction. Okay. Okay, what is happening? Yes. Yes, Russell. Alright. So let's see. Let us see. So what is kinetic friction? So kinetic friction, as I said, would be the force that is opposing when the slipping has started between the two surfaces. So alright, so what do we know about kinetic friction? So I already noticed from experiments that kinetic friction has a constant magnitude. Alright. Now also it is independent of the area of contact. Alright. So that is another interesting thing. That is another interesting thing. Suppose if you have this and if you are applying a force here, so I will see a kinetic friction. If I kept this phone like this and if I moved like this, now also I will realize that the kinetic friction is same. So kinetic friction force is independent of the area of contact. Alright. So please remember this. So when a body is kept on a surface and let's say there is a block which is kept like this, and then there is a block which is kept like this. In both these cases, turns out, in both these cases, if I apply a force F and there is slipping happening, if I apply a force and there is slipping happening, in both these cases, the magnitude of friction would be the same. Alright, so please remember this. The magnitude of friction acting would be the same. Okay? It is independent of the area of contact. Does not change if you change the contact area. How does that happen now? How does that happen? Hello Noman, how are you? So don't you think that okay, friction should be more when the area of contact is more? I did reply Russell. 1 point also is same. Okay, okay, all right. No, it's not more. Why not? Why not? Just hang on a sec. Think about it. Think about this while I just come back. Yes, Ashu Singh, please stop spamming the chat. All right, I will not appreciate it. Okay. Anyhow, so as I was saying, so why do you think the force of friction did not increase when I increased the area of cross section? Area of 1 point be same. Okay. Okay. Yes. So you guys are thinking on the right line. So see, what is happening is that when you have kept the areas like this, all right, and when you have kept this like this, so what you will realize is that in this condition, the number of cold welds that will form would be more. Why? Because there will be more contact points. And in this point, the number of cold welds will be lesser. However, in this case, the pressure on each cold weld will also be reduced. We take body as a point mass. No. That is not the point. That is not the point. The point is that though the number of cold welds would reduce, so will the pressure, and the strength of cold weld is directly proportional to pressure. Alright. So if you kept it like this, maybe here there are 5 cold welds, here there are 2 cold welds only, but on these all 5 cold welds, the pressure would be smaller. Alright. Pressure would be smaller. Okay. So remember this. So because of smaller pressure, these bonds would be weaker and this would be stronger. Alright. So please remember that. Next, this is independent of the relative velocity of motion. So please remember this. If this is moving by 5 meter per second, then the force of friction would be the same even if it is moving by 15 meter per second. Alright. So please remember that the force of friction would be not different even for different velocities. Alright. So please remember this. Then again, okay, Mr. Ashu Singh, whoever you are, you need to seriously stop spamming in my lecture. Okay, next it says this force is directly proportional to the normal reaction between the contact surfaces. Alright, so please remember this. This is again a very important. If you have kept like this, then if I see the force of friction which is acting on it when it is moving, yes, I will block him. Don't worry. Alright. So suppose if this is kept like this and if I'm moving this, then if I see certain amount of friction acting, if I increase the normal reaction, if I keep something on top of this, now I will see that the force of friction would have increased. Okay. So please remember that. So experimentally we have found that this force is directly proportional to the normal reaction between the two contact surfaces. Okay. Please remember this. So since force of friction is directly proportional to normal reaction, I can say from this, if I introduce a proportionality constant, I get an equation force of friction is equal to mu k times n. Okay, where mu k is called the coefficient of kinetic friction. It is a unitless constant. Alright, so if I introduce a proportionality constant, this is what I get. Alright, mu k depends purely on the nature of the two surfaces and is determined experimentally. So the coefficient of proportionality that we introduce is called the coefficient of kinetic friction. Alright. So please remember this. Next, how about problem solving with kinetic friction? So problem solving where there is kinetic relative slipping is easy. No friction is directly proportional to mass. Friction is not directly proportional to mass. It is directly proportional to normal reaction. Please remember that, Raja. It has got nothing to do with mass. Friction has got nothing to do with mass, only to do with the normal reaction. Okay. Please remember that. Alright. So as I was saying, the problem solving when there is slipping is relatively easy. So what do? You know, in such cases, the friction acting is kinetic. Okay. So the moment you know, if you see slipping between two surfaces, you immediately know that the friction would be kinetic. Now the direction of kinetic friction is very easy to judge. So this direction is always opposite to the direction of relative motion between two surfaces. Please remember this. The direction of friction force, kinetic friction, is always opposite to the direction of relative motion. Please remember relative motion between two surfaces. So suppose if you have this, if this block was kept on a plank and if the plank was moving with 20 and this block was moving with 10. So what would be the direction of friction on the block? So this is a block, this is a plank. So what would be the direction of friction that the plank applies on the block? Tell me, what would be the direction of that? Alright, come on, try. The friction force always acts opposite, kinetic friction always acts opposite to the relative motion. Alright. So what do you think is the force of friction? What is the direction of force of friction on block B? Tell me quickly. Forward, yes, absolutely. Because with respect to this, the block is actually moving backward. Okay. So that is why the friction on this will act forward and of course the friction on this will act backward. Because these are action reaction pairs, so they have to act in equal and opposite directions. Alright, so you got that right. So always remember this. The friction does not oppose motion, it is only opposing relative motion. Always get this clear in your head. People are always confused about this. So now, this always takes up a fixed value. So the moment I see slipping, I immediately know the direction. And I immediately know the magnitude also. The magnitude of this friction will have a fixed value, which is mu k times n. Alright, we have seen it from experiments that this guy has only one value, which is mu k times n. Alright, so please remember this. Once the direction and magnitude both are known, then all you need to do is solve your questions by using F equals ma equation. So this is how we will be solving problems with kinetic friction. First we will judge the direction, then we will judge the magnitude. For magnitude, we will find the normal reaction. Mu k would be given to us. Then we will find the force of friction. Now, just like any other force that we were counting earlier in our FBTs, I will also include my friction. Now, I will include that in my F equals ma equations and get the answers. Okay. So, why don't we try this? So, a block of mass 0.5 kg is moving on a rough horizontal surface with an initial speed of, what is mu k? Mu k is the coefficient of friction. I told you here. Experimentally, I noticed that force of kinetic friction is directly proportional to normal reaction. Okay. I hope you know what proportionality means. If A is directly proportional to B, then that just means A by B is constant, right? A by B is constant. That is what it means. If you double the value of A, B will also double. So the ratio of A and B remains constant. Okay. So if this is proportional to this, then I can say that force of kinetic friction, alright, upon capital F would be a constant. This is what I am calling mu k. This constant I am calling mu k. Mu k is the coefficient of kinetic friction. Okay, it is the ratio between the force of kinetic friction to the normal reaction, which is always a constant. Alright. And I'm saying that this is a unitless constant because I'm taking ratio of force is to force. So if the ratio is between two forces, then the ratio will not have any dimensions, and also the value of this depends on the nature of the two surfaces. Alright. So if you have two smooth surfaces, then you will realize the mu k would be smaller. If you have rougher surfaces, then the mu k would be greater. Alright. So the value of mu k depends on the nature of the two contact surfaces. So, alright, so why don't you try a problem here? This problem says a block of mass 0.5 kg is moving on a rough horizontal surface, had an initial speed of 4 meters per second. Alright, if it comes to stop after moving a distance of 2 meters, find the coefficient of kinetic friction between the block and the surface. Now, does the answer depend on the mass? Alright, so try this problem and let's see if you can solve this. Alright, so try this problem, Noman and Raja Dubey. So try this problem, guys. Okay. So how do you think you will solve this? Let me know fast. No, sir. What no? What no, sir, Pawan? Okay, it doesn't depend on the mass. I think that is what you're trying to say. So yes. So let's see what the situation has been told to you. The situation told to you is that this is a 0.5 kg block which is initially moving with 4 meters per second. It comes to stop in 2 meters. So after 2 meters its V is 0. This was its U. Alright. So if it came to stop, then I can find the acceleration. Okay, 2. Are you sure? Mu k is 2. or maybe 0.2. So let's find the acceleration from here. So I can say that v square minus u square equals 2as. That gives me v square is 0 minus u square is 16 equals 2 into 2 into 8. So I'm getting my acceleration as minus 4. So acceleration is minus 4. Force of friction is 2. Not the coefficient of friction. What have I asked? What have I asked? Yes. So I have asked the coefficient of kinetic friction. Alright. So see, you have this equation that force of kinetic friction is mu k times n, right? So what the question will do is either they will tell you things and you will find this and you will find the acceleration, or they will give you the acceleration because of which you can find this and you will either have to find this. Alright, so these are the kind of questions that will be given to you. Alright, so please remember this. So once you have acceleration as minus 4 meter per second square, let's see what I can do with that. Now I know this acceleration is being caused by force of friction. Because when it is moving, the only force which is opposing it is friction. And since it is moving, so this force has to be kinetic only. So since it has to be kinetic, I know F would be equal to m times A. Alright. And the direction obviously is suggesting that it would be in the opposite direction. So it would be negative. Alright. So yes. Yes, Pawan, you are right. So the force of friction would be equal to ma. So force of friction comes out to be 2 Newton. Now I also know that force of friction is mu k times n. So this is 2. So which gives me mu k is 2 over n, and n from here I will see is mg. So what is the n? N is the normal reaction on the surface on which friction is acting. So please remember this. So n will be equal to mg, which is 0.5 into 10, which is 5. So obviously mu k is 2 over 5 as rightly said by Pawan. Okay, no problem. So that is 0.4. Alright, and of course no units with that. So this is one kind of question that you can solve. Next, let's talk about another example. So here in the figure shown, you have been told a mass m1 which is 6 kg and mass m2 which is 4 kg are hanging like this. You have to find the acceleration of the blocks if the coefficient of kinetic friction between m1 and the table is 0.5. And you have been given that the slipping is taking place. Alright, so find the answer of this. Find the answer of this quickly. What will be the acceleration of the two blocks? Alright. Find the acceleration of the two blocks. So let's see you guys try this. Again, remember this can also be solved by using the initial tricks that I told you. You can consider both of them as one system. So please remember that. This time, this guy will have a force that will be pulling it. Okay. 1. Okay. So let's see. Yes. That may be correct. So you have been told that the slipping is happening. If the slipping is happening, this guy will feel a force of 4g, which is 40 Newton. Alright, let's talk about this guy. This guy will have mg, which is 60, and it will have n, alright, and it will have a force of friction. So if I consider both these masses of 4 kg and 6 kg as one system, so I will realize that if I make a combined FBD of them, so here this guy has been pulled by 40, this guy has been pulled by kinetic friction. Alright. So this is of 4 kg, this is of 6 kg. What is the value of F? The value of small f is mu k times n. Mu k is 0.5, n is 60. So this turns out to be 30. So what is the net force? Net force which is driving this. So F net, the net force which is causing the motion is 10 Newton. So the acceleration would be summation F net over total M. So you will have your answer as 10 over 10 equals 1 meter per second square. Alright. Okay, so this is how you solve this. You could have also written different equations for different masses. You could have written 2 equations, 3 equations, and then solve 3 equations. But you can solve it directly also, like I have told you earlier how to solve this. If you don't know about this, then you can watch my earlier videos. Okay. Next, let's try another practice problem. Alright. Let's try another practice problem. Here you've been told a boy slides a flat stone across a frozen pond. The stone has a mass of 100 grams. And of course, you will realize that in the earlier one, the answer does not depend on M. Why? Because essentially mu was MA over MG. So M actually gets cancelled. So here M gets cancelled and A by G was the answer. So the mu K answer did not depend on M. Alright, so let's try and solve this one more. Please give me timetable. Okay, so I come online for Mondays, Wednesdays and Fridays at 4 for class 11th, and Tuesdays, Thursdays and Saturdays at 4 for class 12. Alright, that is my timetable. Okay. So let's try this problem. Here you've been told a boy slides a flat stone across a frozen pond. The stone has a mass of 100 grams and coefficient of friction mu between the stone and the ice is 0.1. Alright. So if nothing is mentioned, by the way, if nothing is mentioned, then coefficient of friction means both coefficient of static friction and coefficient of kinetic friction. So we already studied the coefficient of kinetic friction. I will tell you what coefficient of static friction is later. Alright. So even if the question does not say that this is the coefficient of kinetic friction, even if it just says coefficient of friction, that means it is coefficient of kinetic friction also. Okay. So the coefficient of kinetic friction is 0.1. The stone has an initial speed of 8 meters per second. How far will the stone travel before it comes to rest? Alright, so let's try this. Try this problem. Try this quickly. Okay. So just quickly try this problem and give me the answer. Okay. 4 by root 5. Okay, let's see. So you've been told this is 100 grams, so 0.1 kg. 0.1 kg is moving with an initial speed of 8. So U equals 8 meter per second. And I have to find in how much distance will it stop. So when it stops, my V would be 0. And what is the force that will be acting on it? What will be the force that will be acting on it? The force acting on it would be the friction. Alright, so this friction would be acting on it. And I know how much this friction would be. This friction would be mu times N. So mu is 0.1 into N is 0.1 into 10. So mg. So this is the force of friction that is acting on it. So I got the force of friction as 0.1 Newton. Now this will cause a retardation. How much will be the retardation? So retardation would be A would be equal to 0.1 over 0.1. Alright, force upon mass. So that will be 1 meter per second square. That will be the retardation. Alright, so I don't know what you are doing, Pavan. Now the answer is very simple. All you need to do is apply V square minus U square equals 2AS. And since this was the retardation, I will take the value of this as negative. Alright. So V square is 0 square minus 8 square is 64. Should be equal to 2 times minus 1 times S. Okay. So S is 32 meters. That is the answer. No, why root 32? Why root 32? Just 32. It's 2AS, not 2AS square. Okay. 32 is the answer. That's it. Alright. Raja Dubey, did you also follow this? So all you need to do in such situations is just find the force. And when you find the force, find the acceleration, and that's it. Okay, solve them. Okay. So alright, this is where I would like to wrap it up for today. We will carry on our discussion on this day after tomorrow, where we will discuss about static friction. Alright. Okay. Okay. So I will have all this discussion. I had planned all this discussion today, but we got slightly delayed because of the internet problems. Alright. So don't worry, don't worry. I will talk about all this. Hi Hemlata. Hello Ritika. Alright. So we will carry forward this discussion on Wednesday. Alright. Hi Hemlata. I said hi to you. Alright. So before I leave you, let me remind you, if you haven't gotten your Unacademy subscriptions yet, you should be doing that. And this is how you do it. Once you install the app, go to the plus section in your app, select your goal as IIT JEE and click on get subscription button. Alright. And these are the new prices that you have to pay. Alright. So for 1 year and 2 year courses, the subscription fees have gone up, which if you use RD Live would come down to these prices. Alright. These are still very competitive prices compared to the prices that you're paying everywhere else. Alright. Now, remember when you're paying to use this code, here it will be written, do you have a code? So when it says do you have a code, all you have to do is just write my code RD Live there. Alright. And then you can proceed to pay. Now, if you're feeling that these fees are high, then you have the options of no cost EMI. You can break these payments into any number of installments also if you want. Alright. So please remember, Unacademy doesn't want to burden any one of you guys. So this payment will not really hurt you much. Alright. If you like today's video, then press the like button and share it with all of your friends. For those of you who can't afford these subscriptions, we are providing free quality content, alright, on this Unacademy JEE English channel. So make sure more and more students are benefiting out of this. So like the video, share the video, press the bell icon, and the PDF of all the notes, of all the slides used in today's lecture would be available for download in a couple of days. Alright. So if you're following us on the JEE English channel, don't forget to connect with us on the Telegram app using the link shown above. Alright. Now please remember to use this code RD Live when getting your Unacademy subscription and enjoy a 10% off. So I'll see you next on Wednesday. Till then, keep practicing, guys. Alright. And take care.